The first thing you start with is you take the derivative of f of x here to find critical points. And so the derivative of e to the 2x itself is going to be e to the 2x times the derivative of its inner function, which is this power right here, 2x, giving you this constant 2. And then we move on to the next term where I'm going to bring the minus 5 outside of it. And the derivative of e to the x itself is going to give you the same function. And then the plus 6, of course, will drop off. Now, when you simplify this derivative function, f prime of x is going to be 2e to the 2x minus 5e to the x. And so for finding critical points, we are interested in two things. Number one, for this derivative function here, is there any restriction in the domain where the output would be undefined? And the answer is no, right? Because unlike the natural log function, e to the x is defined everywhere. The second thing of interest is we want to now go ahead and set this to a 0 for f prime of x to find all values of x in the domain where the derivative function is 0, because that's going to potentially mean something, which I will show you later in the video. But before I do that, I want to first just factor out this e to the x, because now when I want to solve for this all equaling 0, it becomes a lot simpler, because check this out. For this expression here, we know that e to the x itself can never be 0. So what that's telling us then is that this inside part, 2e to the x minus 5, is the only thing here that could ever be 0. So when we try and solve for what value of x makes this 0, I'm going to add 5 to both sides. And then when I divide 2 on both sides and then take the natural log of both sides, this tells us that the value of x, where this is going to be true, is natural log of 5/2. So then what do we got to do with this now? We now need to go back to our original f of x function, and we need to find the point where this is a critical point. So I'm going to go back to the original function f of x, not the derivative function. And so f of the natural log of 5/2, basically telling us wherever we see an x now, we're going to plug in natural log of 5/2. We'll give you now this expression on the right-hand side here. Now keep in mind here that for this term, e to the 2 times natural log of 5/2, we can use a property of logarithms where this 2 can actually be brought inside the argument and squares the 5/2. And the reason why I'm doing this is because now it's very clear that for this expression here, e to the natural log of something is that simple something. The e in the natural log essentially cancels out, giving us now this simplified expression where now on the left here, 5/2 squared, we know it's going to be 25/4. And I want to rewrite all my terms here in terms of fourths, giving me this new expression where it's very easy now to simplify this by combining all the fractions, giving us a value of negative 1/4. And so what that's telling us is that in the original function, we have a critical point at natural log of 5/2, which is the x value we found where the derivative was 0, and the y output is going to be negative 1/4. And so this is step 1, but now we're interested in whether this means something. Does the critical point mean that it's specifically a local minimum or maximum value? And before I show you that, which was going to be that bonus tip I promised, if you're finding value in this video and you want more tips and tricks for your math exam, be sure to ninja kick that subscribe button, and it helps me to produce more videos that you guys enjoy. So now what I want to do is I want to take this a step further and determine if that point is a local minimum or maximum. So what I'm going to do now is, remember we found that f prime of x equals this expression here, and this is before I factored out the e to the x term. What we want to do is now find the second derivative, so f double prime of x, because the sign of that result is going to tell us whether the critical point means something in particular. So f double prime of x, using the chain rule again, is going to give you 4e to the 2x minus 5e to the x. And now once again, the x value at the critical point, natural log of 5/2, you're going to take it and plug it into this f double prime of x function that you see here. And that's going to give you what you see on the right-hand side. And once again, we can use properties of logarithms and simplify terms quite a bit. And so you're going to end up with 4 times 5/2 all squared minus 5 times 5/2. And then when you combine all the terms and simplify the expression, you're going to get 25 minus 25/2, which we know we can write 25 as 50 halves, giving you this result that's 25 over 2. Now, the number here doesn't matter so much as it is the fact that it's positive. So what this means is that if the second derivative at the critical point is greater than 0, this means in particular that the critical point is going to be a local minimum, which is basically going to look like a concave up U or valley in your original graph.